Question number 6 asks to find the linearization at a equals 1 or at a equals 0, which means my x naught is at 0. So first thing I'm going to do is work out my initial y position. So I'm going to do the arc cos of 0. So the arc cos of 0 is going to be at pi over 2. Okay, the cosine value is at 0 when we're at 90 degrees. So that's my initial position. Again, I need to find slope to be able to find my equation for my local linearization. So calculating slope, I need y prime. The derivative of cos is going to be 1 over negative square root of 1 minus x squared. Okay, so there's my derivative. I'm going to use that to calculate my slope value at x equals 0. So f prime of 0. When I plug that in, I'm going to get a slope of negative 1. I can then use that to get my L of x. So this y represents my L of x function. Okay, so maybe I'll write that as L of x. So L of x is equal to my slope of negative 1, x minus my initial position. So my initial position is x equals 0, y equals pi over 2. So there's my local linearization formula. So the question also asks to calculate f of, in this case, is going to be 0.1 plus 0 plus 0.1, which is f of 0.1. And we're going to say that that's approximately equal to the L value at 0.1. And when I calculate that, when I plug in 0.1, I'm going to end up with pi over 2 minus 0.1. Okay, and typing that into my calculator, pi over 2 minus 0.1, that's going to be, so pi divided by 2 minus 0.1, I get 1.47. Okay, so then actually working out the value of the arc cos of 0.1. So if I do f of 0.1, the actual value is going to be the arc cosine of 0.1. So putting that into my calculator, the arc cosine of 0.1 gives me a value of 1.47. Now the fourth decimal place is going to be different, but the first two decimal places are exactly the same. So they're essentially, these are very close approximations to each other.